In this lesson, you will learn how to find areas of irregular shapes. Before we can do so, though, however, we need to learn or remember how to find the area of a rectangle. Remember from earlier grades that the area of a rectangle is given by the length times the width. So for this rectangle here, it doesn't really matter which side I call the length or the width. You basically just multiply the two dimensions together. So in this case, you'd multiply 3 feet times 10 feet, and you would get 30 feet squared for the area of this rectangle. The area of a circle is given by pi times the radius squared. R represents the radius. Pi is a mathematical constant. Okay, so for this circle in particular, notice that the radius is 3 feet in length. So the area of this circle would be pi times the radius, which is 3 squared. 3 squared is 9, so I have 9 pi, which if you evaluate this in a calculator, you get approximately 28 feet squared. So the area of this circle is 28 feet squared. Okay, so the first example, we're going to try to find the area of this irregular shape here, parking lot, by splitting it up into simpler shapes. Notice that it's rectangular except for the area taken up by the buildings on the two corners. Okay, so this is actually a parking lot here, and these are the dimensions of these sides. Alright, so one way that we can find the area of the parking lot here, the shaded region, is to divide it into rectangles, since it's simple to calculate the area of rectangles. We can then add the areas of the rectangles which compose the parking lot. So I can divide essentially this parking lot up into 1, 2, 3 rectangles. I'm going to call this one the top rectangle, the middle, and the bottom rectangle. Notice here, in order to find the area of this shaded region, I need to find the area of these 3 individual rectangles. But in order to do that, remember the area of any rectangle is the length times the width. So I need to find out the unknown dimensions in my 3 rectangles. So if we start with the top one here, notice that this length here, you can call this the width if you'd like, is 300 feet because it's exactly the same measure as this here. So this is 300 feet. While this here is 700 feet, since it would be the same as this measure here, given to us, 700 feet. Same thing here. I know that this length here would have to be 300 feet here. This has to be 300 as well, because altogether I have on this side 300 feet plus 500, so altogether this is 800 feet. So if I have 200 here and 300 here, together that's 500, so that leaves me with 300 feet for this piece here. And notice that this here has to be 600 feet, this dimension of the rectangle on the bottom. Okay, because notice that the length across the top of the parking lot is 700 plus 300, which is 1,000. But I have 400 feet here, so what I have left over, if I take 1,000 subtract 400 feet, I get 600 feet. So now I know the dimensions of all 3 rectangles, and I could find their areas and add them up. So notice once again that the top rectangle here, this rectangle, measures 700 feet in width by 300 feet in length. Once again, it doesn't really matter which one you call the width and the length, just depends on your perspective. So the top rectangle's dimensions, like I said, is this here. The middle rectangle is 1,000 feet by 300 feet. So this measures 1,000 feet. 600 plus 400 is 1,000, so 1,000 times 300 feet. The bottom rectangle measures 600 feet by 200 feet. So 600 by 200 feet, because this length is the same as this length here. Alright, so if you do your multiplication, you'll find that when you add up the top plus the middle plus the bottom, you get these numbers here, which ultimately all three of these rectangles added up equaled the area of the parking lot, so that would be 630,000 square feet. Remember, come prepared to class with answers to these questions. I may in fact do a notes quiz where I ask you what's your answer to, for example, reflect 1A or reflect 1B. Okay, another example. This time we're going to use subtraction. Before we used addition to find the area of the parking lot by adding up the rectangles. This time we're going to use subtraction, and you'll see why. Okay, so this is a garden here. This figure here represents a garden. 2 quarter circles in the square garden are going to be covered with gravel, so these 2 quarter circles here. So this region right here represents a quarter circle. This one represents a quarter circle. Okay. So what we're going to do is, or our strategy is to first find the area of the square and subtract away the area of these quarter circles because we're interested in this area here. Okay, so if you remember, the area of any circle is pi r squared. But if I'm looking at the area of this small quarter circle, okay, this small quarter circle here, then I'm going to have to take 1/4 of the area formula of a circle, which is going to be 1/4 times pi times the radius of the quarter circle squared. If you notice, the radius of this circle here is 20 yards, so I just substitute that in for the radius, and I end up getting 100 pi yards squared. For the moment, we're going to leave 100 and pi unmultiplied. I'm just going to leave it like this so that I have a more precise answer. You want to avoid calculating too early so that in the end you come up with a more precise answer. Alright, so we found the area of the small quarter circle, so let's move on to the area of the larger quarter circle. It's the same exact idea. So if you imagine an entire circle here, okay, this is going to be exactly 1/4 of it. So the area of this quarter circle is going to be 1/4 the area of the whole thing. So the formula I'm going to use is 1/4 times the area of an entire circle. So that'd be 1/4 times pi times the radius squared. But notice that the radius of this thing is 40 yards. So I just substitute in 40 for r, right here, substitute in 40 for r. And I end up getting, once I multiply through, 400 pi yards squared. And once again, I'm going to leave it in this form to have a more precise answer. Okay, so now I found the area of these 2 small quarter circles, or rather the large quarter circle and the small quarter circle. So what I need to do is subtract these things from the area of this square. If you remember the area, in order to find the area of a square, you just multiply side length by side length. Okay, so notice here that each side length of this square measures 80 yards, 40 plus 40 here, 60 plus 20 here. So in order to find the area of this square, I just multiply 80 times 80. That gives me 6,400 square yards. Now, I'm interested in finding the area of the unshaded region. So what I do is I take the area of this entire square and I sort of cut out or subtract the areas of these 2 small quarter circles, which would give me 6,400 yards squared minus 100 yards squared minus 400 pi yards squared. Okay, so altogether, if I combine these things, 100 pi minus 400 pi, I'm going to end up getting 6,400 minus 500 pi yards squared. Okay, this is an acceptable answer because it's actually more precise than actually multiplying through 500 and pi. Because any decimal expansion you have for pi, you're going to lose precision because pi never terminates. You can always have a more precise estimation of pi. So this right here is our final answer for the area of the unshaded region. Okay, so the question we were trying to answer is, how do you find the areas of irregular shapes? What you want to do is, you want to basically break it down into things that you already know how to find the area of. So you want to identify the simpler shapes within or around an irregular shape and find the areas of the simpler shapes. If the simpler shapes make up the irregular shape like they did in the parking lot example, example 1, then you're going to want to add the areas together just like we did. Now, if the simpler shapes are outside the irregular shape, like in the case of the garden problem, then you're going to want to subtract their areas from the area, this should be area, this is a typo, from the area of the overall region. Okay, so in your notebook, what I want you to do in order to summarize, and this may be a notes quiz question as well, is to make up and solve a problem involving areas of irregular shapes of your own. Make sure you include a complete solution and a diagram.